Namaste everyone. In the last class we have discussed about adjoint of matrices. Some problems are solved in the last class. We will continue today. Next problem is, if A equal to 3, 1, minus 1, 2, show that A square minus 5A plus 7I equal to 0 matrix and hence find A inverse. Here first part we already discussed in matrix or matrices chapter. We will prove that. First find A square. What is A square? A square equal to A into A. A is given 3, 1, minus 1, 2 into A, 3, 1, minus 1, 2. This is equal to 3 into 3, 9, minus 1. First row, second column, 3 plus 2. Second one, minus 3, minus 2. Multiply second row to the second column, minus 1. Here, second row, second column, minus 1. Here, 2 into 2, 4. Now, we need to find out 5A. 5A equal to 5 into A. A is 3, 1, minus 1, 2. This is equal to 15. 5 into 1, 5, minus 5, 5 into 2, 10. Next one is 7I. 7I equal to 7 into I. I is 1, 0, 0, 1. This is equal to 7, 0, 0, 7. Here, let us apply to LHS. A square minus 5A plus 7I. This is equal to, what is A square we have? This is the value of A square. 9 minus 1, 8. 3 plus 2, 5. Minus 5. Minus 1 plus 4 is 3. Let us substitute here. 8, 5, minus 5, 3, minus 5A. We have here 15, 5, minus 5, 10, plus 7I, 7, 0, 0, 7. Now, this is equal to, say, 8 minus 15 is minus 7 plus 7, or we can write all the values here. 8 minus 15 plus 7. This one. Second one, 5 minus 5 plus 0. Next value, minus 5. Minus into minus becomes plus 5 plus 0. Okay. Next one, 3 minus 10 plus 7. This is equal to 8 minus 15 minus 7 plus 7, 0. 5 minus 5, 0. Minus 5 plus 5, 0. 3 minus 10 minus 7 plus 7, 0. So this is equal to 0 matrix. This is the first part. A square minus 5A plus 7I equal to 0. Hence find A inverse. Hence find A inverse means, here using this equation or matrix equation, we need to find A inverse. We have here first part already proved, that is A square minus 5A plus 7I is equal to 0 matrix. Now, hence find A inverse. Multiply by A inverse on both sides. What you will get? A inverse into A square minus 5A plus 7I equal to, pre-multiplying here. Here also we need to multiply A inverse into 0 matrix. What it becomes now? A inverse, A square can be written as A into A minus, multiply by A inverse, 5 into A inverse into A plus 7 into A inverse into I is equal to 0 matrix into any matrix, that is 0 matrix. Now A inverse into A, we know that already. A inverse into A is I into A minus A inverse into A, that is I, plus A inverse into I, that is A inverse, this is 0 matrix. Now we need A inverse here. Let us take these terms into other side. What is that becomes? 7 A inverse. This is equal to, let us take this one into other side, minus 5I becomes plus 5I. Take this into other side. I into A is A itself. So 5I minus A. What is A inverse now? A inverse equal to 1 by 7 into 5I minus A. Okay. Now this is equal to 1 by 7 into 5I. What is 5I? 5, 0, 0, 5. Minus A. What is A? A is 3, 1, minus 1, 2. Now this is equal to 1 by 7 into 5 minus 3, 2, 0 minus 1, minus 1, 0 minus of minus 1 plus 1, 5 minus 2, that is 3. This is the value of A inverse. Here, if the question is hence find A inverse, we have to find A inverse using this method. We cannot use that A inverse equal to 1 by determinant of A into adjoint of A. We can verify by using this formula. 1 by determinant of A. What is the determinant of A? A is given that 3, 1, minus 1, 2. Right. What is the determinant? 6. Minus of minus becomes plus. So 6 plus 1 is 7 into adjoint of A. What is the adjoint? For 2 cross 2 matrix, we can find adjoint easily by reversing this 2, 3. Change the sign here, minus 1 plus 1. So A inverse equal to 1 by 7 into 2 minus 1, 1, 3. Here similarly we can apply for 3 cross 3 also. Next topic, application of matrices and determinants. Here, this is the last topic in this chapter, very important. Application of matrices and determinants. Here, this application means here we are solving system of equation. Using matrices and determinants, we can solve system of equations. System of equations means system of linear equations a1x plus b1y plus c1z equal to d1. Any equation in general, for example 2x plus 3y equal to 5, 3x plus 4y is equal to 7, like that. These are linear equations. In general, system of equations can be written as a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3, like that. Here a system of equations with 3 unknowns. Okay, here using matrices and determinants we can solve system of equations. That means we can find the values of x and y. Okay, we'll see how to find out the solution. Before seeing the solution, we need two definitions. One is consistent and another one is inconsistent. Consistent and inconsistent. Suppose this is the system of equation. A system of equation is said to be consistent if solution of system of equation or solution exists. Here, suppose we have any system of equation, there are two cases. One is solution may be exist or solution may not be exist. Here, consistency means a system of equation has a solution or solution exists. We can say that system of equations are consistent. Suppose solution does not exist, system is said to be inconsistent. Here consistency means solution exists, here solution does not exist. System of equation has a solution, then system is consistent. Suppose solution does not exist, system is said to be inconsistent. Now we'll see how to find out solutions. If a solution exists, how to find out that solution, that is important here. Suppose these are the system of equations. Solution of system of linear equations. Solution of system of linear equations. Here, consider system of equations. In general, same equation system a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. This is a system of equation. First we need to write this in matrix form. What are the coefficients here? A1, B1, C1, A2, B2, C2, A3, B3, C3. These are the coefficients. Let us write that as matrix A. Coefficients of x, y, z: A1, B1, C1, A2, B2, C2, A3, B3, C3. Now unknowns. Unknowns can be taken as matrix X. This is capital X. What are the unknowns here? X, Y, Z. X, Y, Z are the unknowns. These are the constant values. Constant values can be taken as matrix B. What are the constants? D1, D2, D3. Here, now we need to solve this system of equation. Now, you can verify. See, if we multiply this, we will get equal to B. That is A1x plus B1y plus C1z equal to D1. Similarly, A2x plus B2y plus C2z is equal to second one, D2. A3x plus B3y plus C3z equal to D3. So this system of equations can be written as here a system of equations can be written as Ax equal to B. A into x is equal to B. So system of equation can be written as Ax equal to B. Now we need to find out the solution. That means we need to find out unknown values. What are the unknowns here? X, Y and Z are the unknown values. We need to find out that X, Y and Z. That means we need to find out matrix X. Okay? Here there are two cases now. Ax equal to B. Solution may be exist or solution may not be exist. Here A is one matrix. Determinant of A can be 0 or determinant of A cannot be 0. Suppose determinant of A is 0, then A inverse does not exist. Suppose determinant of A is not 0, A inverse always exists. So we have two cases. First one, case 1, if A is non-singular, non-singular means determinant of A is not 0. Okay? If A is non-singular, determinant of A is not 0, that means A inverse exists here. Okay? Here we have Ax equal to B. Okay? Multiply by A inverse. That is because A inverse exists here. A inverse into Ax. This is equal to A inverse into B. Now apply associative here. A inverse into A into X. This is equal to A inverse into B. Now A inverse into A is I into X equal to A inverse into B. I into any matrix X, that is X only, X equal to A inverse into B. Now this is the formula, X equal to A inverse into B. This method is known as matrix method. Here we can get the unique solution for X, Y and Z. Okay, here it will give unique solution. This method is called as matrix method. Here this method of solving, that is called as matrix method. The problems are very important here. Using matrix method, solve system of equations. X equal to A inverse into B. We need to remember this formula. This is the first case. Now second case, case 2. Here first case, if A is non-singular, that means determinant is not 0. If determinant is not 0, A inverse exists. Here if A is singular, if A is singular matrix, now if A is singular, determinant of A is equal to 0, determinant of A is equal to 0. In this case A inverse, here we cannot multiply by A inverse because A inverse does not exist. In this case, to check system has a solution or no solution, we need to calculate adjoint of A into B. Suppose A is singular, that means determinant of A is 0. In that case, we need to calculate adjoint of A into B. In that, suppose if adjoint of A into B, that is not 0, B we have coefficient value, B is the constant values, adjoint of A into B is not 0, then system has no solution. System has no solution. If a system has no solution, we can say that system is inconsistent. In that case, system is inconsistent. System is said to be inconsistent. Okay? Now, suppose adjoint of A into B, suppose this is 0, adjoint of A into B is 0, then here there are two cases. That means system may either solution may exist or may not be exist. In that case, system either consistent or inconsistent. System is either consistent or inconsistent. System is either consistent or inconsistent according as system has, if it is consistent, it has infinitely many solutions. Or inconsistent means no solution. Okay, here first case system is, if A is non-singular, determinant is not 0, directly we need to take A inverse. A inverse exists here, so X equal to A inverse into B. Using this formula, we can find the solution. That means this method is known as matrix method. Now, suppose determinant of A is 0, that means A is singular. In that case, to find solution exists or not, that means to check the system is consistent or inconsistent, we need to calculate adjoint of A. Here we need to calculate adjoint of A into B. Adjoint of A into B, we can use both small letter or capital letter. Adjoint of A into B is not 0, then system has no solution, that means system is said to be inconsistent. Here only first condition problems are there in our syllabus. Second one, here adjoint of A into B is equal to 0. This type of problems are not there. Suppose adjoint of A into B equal to 0. Condition comes in our problem, just write this conclusion. Now, finding infinitely many solution is not there in our syllabus. Okay, so only these two conditions we need to remember. Suppose adjoint of A into B is not 0, solution does not exist, system is inconsistent. Suppose it is 0, system may either consistent or inconsistent according as it has infinitely many solution or no solution. Okay, let us do one problem. Next problem. Examine the consistency of system of equation. First problem. X plus 2y equal to 2. 2x plus 3y equal to 3. Examine the consistency. That means we need to find out here solution exists or not. To find out or to verify this is consistent or not, what is the condition? We need to check solution exists or not. Solution exists or not, that means suppose determinant of A is not 0, directly we can say solution exists. Okay, in that case we can say solution A inverse exists, solution exists here, the system is consistent. Suppose determinant of A is 0, in that case we need to find out adjoint of A into B. Adjoint of A into B we need to calculate. Adjoint of A into B is not 0, we can say system is inconsistent. Suppose it is 0, system may be consistent or may not be existent. That is the procedure. Now, first we will write the system of equation in the form Ax equal to B. What is A here? Let A can be taken as coefficient here 1, 2, here 2, 3. What are the unknowns? There are two unknowns, x and y. What is B? Constants. B is 2, 3. So, system of equation can be written as system of equations can be written as Ax equal to B. Now, first find out determinant of A here. What is determinant of A? That is 1, 2, 2, 3. This is equal to 3 minus 4. This is equal to minus 1. Means it is not 0. If determinant of A is not 0, we can say that A inverse exists here, or we can say system has a solution. In that case, system has solution. System has unique solution. In that case, we can say that system is consistent. In that case, we can say that system is consistent. Second problem. X plus 3y equal to 5. 2x plus 6y equal to 8. Same question. Examine the consistency here. First write system of equation in the form of system of equation can be written as Ax equal to B. What is A here? When A equal to coefficients 1, 3, 2, 6. What is X? Here there are two unknowns, X, Y. What is B? B is 5, 8. Okay. Now we need to find out determinant of A. Determinant of A equal to 1, 3, 2, 6. This is equal to 6 minus 6 equal to 0. See, determinant of A is 0 here. Suppose determinant of A is 0, in that case A inverse does not exist. Okay, here A inverse does not exist. What we need to calculate? In that case, we need to calculate, in this case we need to calculate adjoint of A into B. Here what is adjoint of A? A we have 1, 3, 2, 6. Adjoint of A is, directly we can write to cross to reverse diagonals, 6, 1, non-diagonals, change the sign, minus 3, minus 2. Now we need adjoint of A into matrix B. Adjoint of A is 6 minus 3 minus 2 1 into B. What is B? 5 8. Okay, this is equal to, multiply first row to first column, 6 into 5 30 minus here 3 into 8 24 Okay. Second row, second column, minus 10 plus 8. Here this is equal to 6. Here minus 2. We can say this is not 0. A into or adjoint of A into B is not 0. Then we can say that system has no solution. In that case, system has no solution. In this case, in this case we can say that system is, in that case we can say that system is inconsistent. In that case we can say that system is inconsistent. Try one problem yourself. Here first part we already proved in the matrix chapter, that is a cube minus 6a square plus 7a minus 4i equal to 0 matrix. A cube we need to find out, a square we need to find out, then 9a, a cube 6a square, 9a, 4i, substitute here, okay, we will get 0. Then hence find A inverse, that means multiply by A inverse and then solve. Okay. One more. Examine the consistency. 2x minus y equal to 5, x plus y equal to 4. Okay. Try this. Thank you.